All right, welcome everybody. Today is our review day for Unit 5. Unfortunately, I'm not with you obviously today, but we got a video to go over all of our key concepts, and I'm going to start off how we start off every day with a little warm-up. So for this warm-up, we're going to evaluate a couple trig functions going on with the unit circle. So you just want to think of these as individual evaluating problems. So if you're thinking of sine of 11 pi over 4, you need a coterminal angle with that. So what you're going to do is you're going to think about where that actually falls in the circle. That actually goes around the circle more than one time. It ends with the coterminal spot of 3 pi over 4. So that's the same thing as saying what is sine of 3 pi over 4? And that's going to be root 2 over 2. Cosine of 7 pi over 6 is a little more straightforward. 7 pi over 6 down here in the third quadrant. The cosine value there is going to be negative root 3 over 2. Then it's telling us this operation here is multiplication, so just multiply them together. Negative root 6 over 4. Final answer. There you go. Same idea for number 2, secant squared of 4 pi over 3. So it's going to take a couple steps. First thing you want to think about is what the reciprocal function of that would be. We are talking about cosine of 4 pi over 3. And cosine of 4 pi over 3 is going to get me negative 1/2. But I don't want cosine. I want secant squared of that. So first thing I think of secant of that is going to be the reciprocal of a negative 1/2 is negative 2. Then square. Okay. Minus cosine of pi. Pi is just straight to the left on our unit circle. That y value is, or sorry, the x value there is negative 1. So it's going to be 4 plus 1 is 5. There you go. So these are leveling up our evaluating problems a little bit, but it's really just evaluating a couple features and then multiplying or subtracting or adding or whatever you do. All right, let's keep it going with kind of a little bridge off of that. Similarly to our evaluating problems, we can square our trig functions, we can add them, we can subtract them. So in this case, what we're going to talk about is squaring a trig ratio and then adding it to another trig ratio squared. So you can pick any angle here. We'll start off with pi over 4. So if I want to square sine of pi over 4, I would be squaring the square root of 2 over 2, which would get me 2 over 4, which is 1/2. Again, you can choose any angle. We're doing 2 examples of this, so let's go my favorite unit circle angle. I think it's a good one. 7 pi over 6. So if I were to square sine of 7 pi over 6, that would be squaring negative 1/2. And that would get me 1/4. All right, that's all well and good. Let's continue and do the exact same thing for cosine now. So cosine squared of pi over 4 is, it's actually going to be the same thing. Square root of 2 over 2 squared is 2 over 4, which is 1/2. Cosine squared of 7 pi over 6 is going to be negative root 3 over 2 squared, which is 3 over 4. The reason why we did this is actually an identity that we already know. Find the sum of the results above. When you add 1/2 and 1/2, you get 1. When you add 1/4 and 3/4, you get 1. This is something we proved quickly before, but our fundamental Pythagorean identity says for any value of theta, sine squared plus cosine squared of that angle will always get you 1 no matter what you use. All right, so this gets us into our review for today. A quick overview of our test topics. 5.1 goes back to our first quiz of the unit. It's on angle of elevation, angle of depression, SOHCAHTOA, right triangle trig, and bearings were our big application in there. Then we got into 5.2, which is radians and applications of those, sector area, arc length, angular linear speed. And the key with that is we're always using radians. So look back over those quizzes and think about the key things you remember from those to help you study. And then finally, 5.3 is what we've been really drilling in on recently, which is our unit circle, angles, coordinates, as well as trig, working forward and backwards. You already have a review packet, which is a great resource. The answer keys posted on Schoology for you to check out your answers, as well as this packet of materials that you got for today. And today, our review, it would be whiteboard practice with partners, going through problems and answers together as a class. But instead, you're just going to try it on your own. You can work with a small group, and I'm going to kind of run through my explanation of each. So as you watch this video, please pause it and try out the problem before you just watch me do it. It's key to really test yourself to see if you got these skills down instead of just kind of following my lead. So we're going to start off with applications. The second section is going to be a little more fast-paced multiple choice practice. With that, let's jump in. I do want you again to take a moment, pause this, try it out on your own, and then when you're ready, play it and see if you agree with what I got. So take a moment to pause it. And here's what I'm looking at. Froylan leaves school and bikes 10 kilometers south. So if Froylan leaves school, this is the location he's leaving. He goes straight south 10 kilometers. Then 8 kilometers east. East is going to be over there in the right direction on my diagram here. 8 kilometers. And this is Froylan's path I've mapped to get to Fletcher's house. He's now ended at Fletcher's house. Thank you, Froylan, for making a nice right angle there for us. So we got a right triangle. We're going to find the bearing of the school from Fletcher's house. So I'm going to want to connect this and make a right triangle. And the key with bearings, we're jumping right into bearings. It's where it's from. We're going from Fletcher's house. Even though it says a bearing of the school, it's from Fletcher's house. So what I want to do is find the angles down here at Fletcher's house. Specifically, the angle I really want is that one there, along with the north line. As you can tell, that is not the angle of my triangle. So I will first find this angle here, and it will just be a complement. I'm going to find the angle I've labeled as X. And to find that, we're thinking SOHCAHTOA, and we are thinking tangent inverse because this is our opposite and adjacent legs. So tangent inverse of 10 over 8. It says round to the nearest degree. So tangent inverse of 5 over 8, I'm just going to call 51 degrees. So this is 51 degrees. But again, that is not the angle I want to use. It's asking for a bearing. So my final answer is going to be 90 minus 51 is 39 degrees. So north 39 degrees west, or if you prefer your answer, counting clockwise from due north, it would be 321 degrees. First problem down. All right, let's continue. Number 2. Again, pause it, try it out on your own. In this problem, I'm going on vacation to Mars. I know that the central angle formed between 2 settlements on Mars is 1.7 degrees. That's a really small angle. I'm going to, just for my purposes, make it a little bigger than that. I'm going to label it 1.7 degrees, obviously not drawing the scale. The 2 settlements are on this round object, that is Mars, and I know the distance between those 2 is 62.3 miles. So these things should all be pointing to arc length, which is S equals R theta. The arc length is the length of the arc, the distance around a curved object, so 62.3 miles. What is the radius? That's my question, so I'm going to leave it as R. And a common mistake here is putting 1.7 degrees in here and just dividing it over. You're not doing that. You need to turn it into radians first. This is the application of radians. So on the side, I'm going to do 1.7 degrees times pi over 180 degrees. That's going to cancel my degrees out and get me theta, 1.7 pi over 180. That is fine to leave it like that. Then in solving out, you can either divide by that very small radian value that I get, or you can multiply by the reciprocal. But a key thing to remember is calculator skills. Put your 1.7 pi in parentheses. Make sure you kind of
Keep that together. Your final answer to the nearest mile is 2,100 miles. All right, good job. Let's keep it going with another application problem. Again, pause, try it, restart it when you're ready. We're asked for the diameter of the world's largest pizza with a central angle 10 degrees and a sector area. So there's a couple giveaways. Obviously it says sector area, but also the unit is feet squared. That is my area formula. I just got to think about what I know and plug it in and solve for what I don't know. The area is, okay, so the area A equals 380.133. What is the diameter is what it's asking me. So if I know the radius, I double it to get the diameter. So radius, I do not know right now. And then theta, central angle of 10 degrees. Be careful again, that is in degrees. I need to convert that again into radians. So times pi over 180. So my theta value, I'm going to simplify it. If these degrees cancel and the zeros cancel, it's just pi over 18. All right. Oh, I forgot a very big part. Don't forget your square in your radius there. And I would multiply by 2, multiply by 18 over pi, and you would get this value for r squared. Square root it to get the radius of 66 feet. But be careful, the question's asking for the diameter, so 132 feet. You just got to multiply that by 2. All right. Keep it going. One more application kind of problem here. Again, one more time. Pause it, try it out, restart it when you're ready. Okay, the wheels of Bryn's car have a diameter of 22 inches, so that's going to give me a radius of 11 inches. And they're rotating at 600 revolutions per minute. So right away I know this is angular linear velocity for sure. It also is asking me to find the linear velocity. And the first thing, again, with all these radian type application problems is it's got to be converted into radians. 600 revolutions per minute. I need to multiply by 2 pi to get my angular velocity, 1200 pi radians per minute. With that, I can now think about my equation, think about what I can plug in. The linear velocity is the angular velocity times radius. So linear velocity is what I want to solve for, so I'm going to leave that just as v. Angular velocity is 1200 pi radians per minute times the radius. So the radius, let's see, is going to be 11 inches. And remember, that's the radius. So you can, if you want to think of it in a way that is a little bit neater, 11 inches is the radius, or is a radian length. And that's why when you use this equation, you always must be in radians, and they kind of cancel out. And I'd be left with a value that is in terms of inches per minute. So that value you're then going to want to convert. So I'm going to multiply it by, and you can multiply that out first, you get a very large number. Multiply it by 12 inches is 1 foot. So I'm essentially dividing by 12, and that will get me my final linear speed in feet per minute of 3,455. That's 7.2 feet per minute. And the follow-up question is, all right, how long does it take for him to travel 750 feet? So think about that. It's distance equals rate times time. The distance I want to travel is 750 feet. The rate I'm traveling is what I just found. That's my linear velocity. Times time. divide it over, and you get your time is 0.217 minutes, or about 13 seconds. Just one. All right. I kind of lied. There is one more quick little application problem here, but this is just drawing a picture. Bless you, senor. From the window of his private jet, Kyle can look down at an angle of 57 degrees and see WHS. So what I really want you to focus on here is where the angle of depression is. Here's your plane flying in the sky, looking down at a building, WHS there. The angle of depression is measured on a horizontal line. So that's your angle of depression. I can continue to form really two right triangles here, wherever I wanted to. But this is my plane up here. The angle of depression must be on the horizontal line, not here inside that triangle below. It's not there. So no, not here, on a horizontal line. The follow-up, Daniel's looking up from the school at Kyle's private jet. Looks nice. What angle of elevation would he look up? 57 degrees. Those are alternate interior angles. So the angle of elevation and angle of depression up and down will be equal. All right. That's the end of our application components here. You now have some multiple choice problems that I want you to pause this video and run through your examples really quick. And then when you restart it, I'll share your answers. Thank you. All right, picking up with some multiple choice practice here. Again, you have these on paper, so I want you to pause and try them out on your own. I'm going to fly through the answers pretty quickly, so pause. All right, answer number one is B. You want to find sine at that angle and then flip it. Answer number two is A. That is a fundamental Pythagorean identity, but if you didn't remember that, you could also square each value and add them and get one. Number three, the answer is going to be B2, and that is because cosine of pi is -1, and then tangent squared, well, tangent there is √3, and when you square it, it's -1 plus 3 gets you 2. All right, continuing number four. Number four requires you to draw in quadrant 2 a right triangle. Sine opposite over hypotenuse is 3 and 5. What you need to do is find your adjacent leg, and it's going to be 4, but you want to consider it as -4 because it's going left. So, since it's -4 there, tangent is going to be B, -3/4. And again, when you're at r squared equals 16, a way that you can kind of remember that is you're considering, oh, it could actually be plus or minus 4, and since it's since it's going left, it is negative. Continuing, number 5. Same idea, that is going to be C. Again, in the third quadrant, that's going to be down here. There's our theta. You can put a 5 for the hypotenuse. Your hypotenuse will always be positive. And then -2 here. You'd solve it out to get -20, square root of 21 for the other leg. Continuing, converting to degrees. B, 126. Multiply by 180 over pi. Number 7. You need to add or subtract 360 degrees to find coterminal angles. And if I'm going to find a -1, I want to subtract 360, not once, not twice, but 3 times in order to get our coterminal angle of -335. Find the exact value. You want to consider cosine of 13 pi over 4, and then flip that result. Cosine of 13 pi over 4 is -√2 over 2, so that's going to take us to the reciprocal -√2. Finally, cotangent of theta is -√3 over 3. The place where that is true, 2 angles. the place where a tangent of theta is just negative root 3? That would be asking the same question.
All right, that's the extent of our multiple choice practice. Hope this helps. Keep in mind, continue studying, use all of the review materials provided to you. Have a great day.